In this week's session, we're going to look at algebraic fractions. This takes everything we know about fractions and everything we know about algebra and puts them together. So let's start off with a simple reminder. If we had 3/4 and we were adding 2/3, the first thing we need to do is make sure our denominators are the same. In this case, our easiest denominator would be 4 times 3, which would be 12. I could write it as 12 and 12 as two denominators. It's the same thing as one single denominator. To get from 4 to 12, we multiply by 3, so we must do the same to the numerator. 3 3s is 9. And to get from 3 to 12, I multiply by 4. 4 times 2 is 8. So I have, if I'd written it over one denominator, 9 plus 8 all over 12, which is the same as 17 over 12, which we can also write as 1 lot of 12, 5 remainder out of 12. If you don't remember how to do the fractions, please go back and look at them again. It will become very, very important. Now let's take this up into algebraic fractions. If we have 3x plus 4 plus 2x plus 1, I'm going to put these into brackets just to make it easier to see. We actually only have one option here for our denominator, and that will be a combined denominator. We will have x plus 4 times x plus 1. Now to get from x plus 4 to x plus 4 times x plus 1, we've multiplied by x plus 1. So we must do that to the numerator as well, giving us a top here of 3x plus 1s plus 2x plus 4s. And our next step is to multiply out and collect our like terms. So this is bringing in what we've already learned about brackets. We have 3x plus 3 plus 2x plus 4 on the top, which we'll tidy up in the next line. And on the bottom, we're going to use our face, foil or rainbow technique. And we have x squared plus 4x plus x, remember 1 times x is x, plus 4 times 1 is 4. And now we should tidy up. We have 5x on the top plus 7 over x squared plus 5x plus 4. Now there is nothing further we can do with that. That is our final answer. I'm going to give you another example. If we have, let's see, 1 over p minus 1 plus 3 over 3p plus 5. That's rubbish. What we get is our denominator as p minus 1 times 3p plus 5, and our numerator 1 lot of 3p plus 5 plus 3 lots of p minus 1. And again, tidy up once you've multiplied out your brackets. So I've got 3p plus 5 plus 3p minus 3. A plus times a minus is a minus. And multiplying out our bottom, 3p squared minus 3p plus 5p minus 3. Let's tidy that up. We end up with 6p plus 2 over 3p squared plus 2p minus 3. Like I say, if you're unsure at all about these, it's worth going back over and practicing normal fractions and then practicing your algebraic information. Now the next form we get them in is usually one that will require us to do something with it. So we'll get something that requires us to factorise, like x squared plus 5x plus 6 over 3x plus 6. Now remember, your first step in factorising, you always want to look for a common factor first, and this bottom denominator here has 3 as a common factor. So I'm going to change that into x squared plus 5x plus 6 over 3 lots of x plus 2. And especially at Nat 5, what you find happens with questions that are suspicious like this is that part of your numerator, or part of your unknown that you're going to have to factorise, will include whatever they've handed you. In this case, x plus 2. So I'm suspicious that this x squared plus 5x plus 6 will give me an x plus 2 bracket and another bracket. But let's investigate that first. So we have, just looking at the top here, x squared plus 5x plus 6. Just taking that, we know that we're going to have 2 brackets because we've got an x squared. And we're going to have a couple of options for the end. It could be 1 times 6, or it could be 2 times 3. We've got a plus here, so we know both signs are the same. We've got a plus here, so we know they're both pluses. So we've got plus, plus, oops, x plus. And now we want to know 2 things that add together to give us 5. 1 plus 6 is 7, so it's not that. 2 plus 3 is 5, so it's that we're looking for. X plus 2, x plus 3. So we've got that x plus 2 I was expecting. So let's put that in. We have x plus 2, x plus 3, all over 3 lots of x plus 2. And now we can cancel. On the top we have x plus 2 multiplying, and on the bottom we have x plus 2 multiplying. So they cancel, giving us our final answer of x plus 3 all over 3. You can put it in brackets if you want. If you really fancy carrying on from there, or if it helps answer another part of a question, you could also split it up into 2 items, x over 3 plus 3 over 3, which is the same as x over 3 plus 1. Sometimes a question, especially if it's towards the very end of a paper, will ask you for an answer in this sort of form. So watch for this sort of technique being available to you. It's very, very rare though. So I'm going to show you one more example of that. I'm going to see if I can find it on the past paper. Algebraic fractions. Here we go. So there's two forms here. I've got one that says x minus 2, 4 over x minus 2 minus 3 over x plus 5. And I'm told x is not equal to 2. And I'm told x is not equal to minus 5. Do not try and substitute these in for your x values. That is not what it's telling you. In fact, it's telling you the exact opposite. It's telling you you cannot have a denominator of 0. So these will not be your answer. And they want it as a fraction in its simplest form. So you multiply your two denominators together. And you multiply, or cross multiply if you prefer, your numerators. And then you tidy it up and you write your answer as a single fraction in its simplest form. Now this was taken from the paper 2, the calculator paper, question 15, so quite far towards the end of the paper, and the 2019 paper. So we have 4x plus 20 minus 3x, minus times a minus, so it's plus 6, all over x squared minus 2x plus 5x minus 10. It's not always necessary to multiply out your bottom. Sometimes you find when you tidy up the top that bottom is useful in that format. So I'm not going to ignore that just now. I might come back to using it in that form. So on the numerator we have x, so 4x minus 3x plus 26. We were asked for the simplest form. So it is actually quite legitimate to leave it as x minus 2 times x plus 5. But I've gone to the bother of multiplying it out here, so I am going to write it as the full version. Now I don't have anything common on the top that I can take out. I don't have anything common on the bottom I can take out, so I'll leave it like that. And I know that the very fact that that appears simple will throw a lot of people. It's still the same. It's still the same type of fraction. Just because it's on a question paper towards the end doesn't mean it's hard. Just take your time and do all the steps. So this time I'm looking at the 2015 paper 1, question 12. So this is a non-calculator paper. And I have x squared minus 4x. And I have x squared plus x minus 20 on the denominator. And I'm simply asked to simplify. Let's start off by taking out a common factor from the top. I have x's everywhere, so I can take that out. X minus 4. And on the bottom, I'm looking for two things that multiply to give me minus 20. So I'm going to have x plus something, and I'm going to have x minus something. So multiply to give me minus 20, and they add to give me 1. So my options are 1 and 20, which is 21. Oh, sorry. I tell a lie there, don't I? They've got to multiply to give me minus 20. So I do have minus 1 times 20, or I have minus 20 times 1, or minus 2 times 10, or minus 10 times 2, or minus 4 times 5, or minus 5 times 4. Now I want things that are going to add together to give me 1. So I want numbers that are close together. So 4 and 5 I would say would be my best bets. And I want a positive answer. So I want my positive to be my larger number. So I am going to put positive 5 and negative 4. Now this ties back in to here, where I have an x minus 4, which was highly suspicious to begin with. So if we can cancel out, we end up with x over x plus 5. And we have completed our simplification. Now, we've dealt with addition. Subtraction is the same as addition, same techniques, you know how to do that. We've dealt with simplification, and we've dealt with factorising back into double brackets. There's one more I want to have a look at, again from a question paper. This time we're going to deal with a division. That's an S, not a 5. Divided by, so 5t divided by s divided by t over 2s squared. Now remember, when you have a division in a fraction, you flip your second one and multiply. So you're flipping multiplying. 5t over s times 2s squared over t. I can write this as being all over one denominator. So I can write it as 5t times 2s squared over st. I'm going to have to make that look more like a 5. Right. And now I can write that as 10 s squared t over st. And you can see how you might cancel there. We've got a t on the top and the bottom. We've got an s on the top and the bottom, although we have 2 s's on the top. So we end up with our answer as 10s. Now some of you, way back here, might have been able to do that quicker. You might have noticed you could cancel across the way like that. And then you've just got 5 times 2 is 10s, straight to the answer. If you don't see it, take your time, work through step by step. You'll get to the same answer, it just takes you a little bit longer. The only other ones that you've at risk of having come up is other ways of factorising. So remember your difference of 2 squares, and remember you want to see if you can cancel or find a common factor. That'll help you get to your answer. Good luck.